Learning Module 4 offers an extended treatment of induction, examining several distinct patterns of reasoning that are often used in inductive arguments. It also considers criteria for inductive reliability and concludes with an analysis of inductive strength as an analog to deductive soundness. As always, we want to be clear about our learning goals. Upon completion of this unit, you should be able to do the following: reconstruct inductive arguments, identify 4 specific types of inductive inference by name, including enumerative induction, statistical syllogism, causal argument, and reasoning by analogy. Finally, you should be able to evaluate inductive arguments using the criteria of reliability and strength. Allow me to say a few words about inductive reasoning and its role in critical thinking. Inductive arguments attempt to establish the probability of their conclusions. That differs from deductive arguments. In deductive arguments, we derive conclusions with certainty. Because the conclusions of inductive arguments are never certain, the support offered by the premises is always a matter of degree. The stronger the evidence, the more likely the conclusion. Let me describe the patterns of inductive inference we'll be studying, along with an example of each. In an enumerative induction, we look at specific instances, noting their characteristics, and then conclude with a universal generalization about the instances. Here's an example from astronomy. The Earth, Mercury, and Mars rotate counterclockwise around their axes. Saturn, Jupiter, and Neptune also rotate counterclockwise around their axes. So it seems likely that all the planets in our solar system rotate counterclockwise around their axes. Note that the conclusion is a universal generalization because I am inferring that counterclockwise rotation is common to all planetary bodies in our solar system. But as it turns out, this is mistaken since Venus rotates clockwise. I use this example because it points to an important feature of all inductive inferences. Namely, even if the premises are true, the conclusion might still be false. The second pattern of inductive inference is often called statistical syllogism. You'll remember that a syllogism is a 3-line argument consisting of 2 premises and a conclusion. In a statistical syllogism, one of the premises contains a non-universal generalization, something like nearly all NFL linemen weigh more than 250 pounds. In this statement, the non-universal generalization is nearly all. We use generalizations such as this to provide support for the probability of the conclusion, once we have a specific case to which the generalizations can be applied. For instance, if I know that Jari Evans is an NFL lineman, I can conclude that, most likely, he weighs more than 250 pounds. And he certainly does. A third pattern of inductive inference is causal reasoning, where one or more premises are offered to support a hypothesis in which a cause and effect relationship is conjectured. For example, scientists have recently advanced the theory that the most luminous supernovae, which are commonly called exploding stars, are the result, that is, the effect of small and incredibly dense neutron stars with enormous magnetic fields revolving hundreds of times a second. Is the hypothesis proven? No, but given the evidence, it appears to be a strong probability. What's important to note is that the hypothesis is based on observation and could eventually prove false, as is the case with all inductive arguments. The fourth and final pattern of induction that we'll study is called reasoning by analogy. It's basically reasoning by comparison, using similarities between 2 things to justify the inference that some further likeness exists. Here's an example. In the late 1990s, the Microsoft Corporation was sued for antitrust violations by the federal government, which claimed that Microsoft illegally bundled its Internet Explorer web browser with its operating system to the exclusion of rival browsers, such as Netscape. When Bill Gates, the founder of Microsoft, was asked to comment, he made the following analogical argument. Forcing Microsoft to include Netscape in our operating system is like requiring Coca-Cola to include 3 cans of Pepsi in every 6-pack it sells. Let me conclude by advising you that the discussion board for this unit may take extra effort, since you'll need to apply what you've learned to a complex scientific argument known as the Gaia hypothesis. But I'm not worried. I've discovered that you guys like challenges. Have fun with this learning module.